Today we're looking at solving rational inequalities. So let's see what that means and what that involves. Our first question is use algebra to solve the following inequalities. So our first inequality is -5 over x minus 4 less than 3 over x plus 1. So again, the goal is to figure out what x values satisfy this inequality. So first we're going to try and remove these fractions, so we're going to cross multiply our x plus 1 with our onto the left hand side. So we have -5 times x plus 1 less than, and then 3. We're going to cross multiply the x minus 4 over to the right hand side. So we have 3 times x minus 4. Now we're going to expand both sides. So -5x minus 5 less than 3x minus 12. Now let's bring all the x's onto one side of the inequality and all the numbers, and what do we get? We get 3x plus 5x. We're going to add 12x to both sides. We get -5 plus 12. Sorry, 12, not 12x. So on the left-hand side, we have 7 less than. On the right-hand side, we have 8x. And we're going to divide both sides by 8, and we end up with x is greater than 7 over 8. Good, not too bad. Now let's look at the second one. Okay, this is a bit more challenging. So we have 6 times t squared minus 5t plus 1 all over 2t plus 1, and that is greater than 0. So let's factor. Let's start by factoring the numerator and see if that helps us in any way. Okay, so this factors quite nicely. It has 3t minus 1 times 2t minus 1. So we can check this. So 3t times 2t is 6t squared. 3t times -1 is -3t. And then we have -1 times our 2t is another -2t. We add our -2t and -3t, giving us our -5,3. And then -1 times -1 is +1. Good. Okay. And again, all of this is greater than 0. So now we're going to look at each of the factors. So 3t minus 1, we're going to see when they equal 0. So from here we have t equals 1 over 3. And then from 2t minus 1 equals 0, we have t equals 1/2. And from 2t plus 1 equaling 0, we have t equals -1/2. So we use these values, 1/3, 1/2, and -1/2, to divide up our number line. So let's do this right now, right under here. Okay, so we have our 0. Let's call this 1/2, positive 1/2, -1/2, and then -1/3. So now we've divided up our interval into 4 components. Okay. And we want to determine whether our function here is our function 6 times t squared minus 5t plus 1 over 2t plus 1 is positive or negative on this interval. So let's do that. Let's scroll over to the right a little bit. Okay, so our first interval is when our variable is t. Our first interval is when t is less than -1/2. Second interval when t is between -1/2 and 1/3. Fourth interval when t is between 1/3 and 1/2. And final interval when t is greater than 1/2. Now our factors are 2t minus 1, 2t plus 1. Oh, let's do 3t. Actually, let's keep them all together. 3t minus 1 and 2t plus 1. And then finally, when we multiply them all together, the bottom here, we get our given function. Okay, so let's see how we use this table. So on this table, we're going to determine when our factors are positive or negative. So in this first interval, our first factor 2t minus 1 is negative. And we just go across. We find that we have negative, 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 and positive. We do this. Let's quickly go through this here. Okay, so let's look at the first row. So our factor is 2t minus 1. When t is less than negative a half, this factor has a negative value. When t is between negative a half and 1/3, again, 2t minus 1 has a negative value, so put a negative in there. When t is between 1/3 and 1/2, 2t minus 1 is again negative. And finally, when t is greater than a half, we put a value into our factor 2t minus 1, we get a positive value. So we repeat this process for each of our factors, so 3t minus 1 and 2t plus 1, and then we fill in our chart with pluses and minuses depending on where that particular factor is positive or negative. Now we're going to look down the column and we're going to consider all the signs. So if you notice our function 2t minus 1 times 3t minus 1 divided by 2t plus 1, if we have three negatives, then the product and quotients of those three negatives is going to give us a negative value. In our second column, we have two negatives. Two of those factors are negative, one is positive. So when we take their product and quotient, we're going to get a positive value. In the third column, we have one factor that is negative, the other two are positive. We take the product and quotient of one negative and two positives, we get a negative value. And finally, when we have the product and quotient of three positive factors, we get a positive value in the end. So now we can go and look at which intervals correspond to negative values for our product and quotient, so for our function. So our function is 6t squared minus 5t plus 1 over 2t plus 1. And we were originally given that we want to determine when this is greater than 0. So this is greater than 0 on the interval when t is between negative a half and a third, and when, oh, I have an x there. Let's fix that. And when t is greater than a half. So our final answer is, so our inequality is satisfied for values of t between negative a half and a third, or when t is greater than a half. So that question required a bit of work, but nothing too difficult. Good, so now let's look at the next one. Okay. All right, so again, we're going to use some kind of table. So we need to factor our x squared minus 16 over x minus 1 all squared. So let's do that. So x squared minus 16 is a difference of squares, so it factors quite nicely. Great, so now when is the left-hand side equal to 0? When x equals 4, negative 4, and 1. So these are the values we use to divide up our real axis or number line into intervals. So these are our intervals, less than negative 4, between negative 4 and 1, between 1 and 4, and greater than 4. So now let's scroll over to the right and create our table from these intervals. Okay, the first column is when x is less than negative 4. Second, when x is between negative 4 and 1. Third column, when x is between 1 and 4. And final column, when x is greater than 4. Let's put in our factors, x minus 4, x plus 4. And x minus 1, well, it's a factor, it's squared. It's always positive, so we just put it in as x minus 1 squared. And then our final function that we're interested in is x squared minus 16 over x minus 1 all squared. Oh, okay, so now let's look at the sign of each of our factors in each of these intervals. So x minus 4 is negative. Okay. Negatives all all across until the last interval when x is greater than 4. We'll have x plus 4. Get negative and positive values all across. And finally, x minus 1 all squared is positive right across. So now we look at the quotient x squared minus 16 over x minus 1 all squared. So in the first column, the product and quotient of 2 negative factors and 1 positive gives us a positive. Product and quotient of 1 negative factor and 2 positive factors gives us a negative. And again, we have 1 negative and 2 positive factors. In the third interval, again, another negative result. And finally, in the third column, all our factors are positive. So the product and quotient is positive. So what does that give us in the end? This tells us that our final inequality, x squared minus 16 over x minus 1 all squared, is greater than or equal to 0 when x is less than or equal to negative 4 or x is greater than or equal to 4. Good. So in this case, we have to include the equal because our original inequality is greater than or equal to 0. Okay, so one last question. Let's see what this one is like. So here we have 3x minus 8 over 2x minus 1 greater than x minus 4 over x plus 1. Again, what should we? We're going to cross multiply and try to simplify things, see if that helps us. All right. So if we bring x plus 1 over to the left-hand side, we have 3x minus 8 times x plus 1 greater than x minus 4 times, again, 2x minus 1 is brought over to the right-hand side. Let's expand everything out and see what we get. 3x squared plus 3x minus 8x minus x greater than 2x squared minus x minus 8x plus 4. Let's check. Good. So let's bring everything over to one side and simplify, grouping like terms. So if you bring everything over to the left-hand side, we have x squared. Let's see how many x's we have. We have negative 5 here. That's a negative 9. So we have negative 5x plus 9x from the right-hand side. We have negative 8. And we have a plus 4 on the right-hand side. Bringing that over to the left-hand side, we have negative 12. Okay, almost there. So x squared plus 4x minus 12 is what we have, and that must be greater than 0. Let's see if we can factor this. Actually, we can, which is convenient. The factors of 12 are 6 and 2. Did we get that right? Yes, we did. Good. So what are the values for x when this left-hand side equals 0? So when x equals negative 6 or 2. Good, so we can use these values to now divide up our x-axis or a real number line into intervals. Let's see what those intervals look like. So we have negative 6 and 2. So our intervals are when x is less than negative 6, when x is between negative 6 and 2, and when x is greater than 2. So now let's scroll over to the right-hand side and use this information and create our table. So x less than, we might need a bit more space, x less than negative 6, negative 6 less than x less than 2, and x greater than 2. What are our factors? X plus 6, x minus 2, and then finally the product of the two, x plus 6 times x minus 2. Okay, now let's fill in our table. So when x is less than negative 6, x plus 6 is negative. When x is between negative 6 and 2, x plus 6 is positive, and when x is greater than 2, x plus 6 is also positive. When x is less than negative 6, x minus 2 is negative. When x is between negative 6 and 2, x minus 2 is again negative. And finally, when x is greater than 2, x minus 2 is positive. So now if we go down the columns, we look at the product of our two factors. So in this case, a negative and a negative will give us a positive value. Product of a positive and a negative will give us a negative value. And finally, the product of two positives is a positive value. So therefore, x plus 6 times x minus 1 is greater than 0 when, and we can read off our chart which intervals, when x is less than 6 or when x is greater than 2. So our inequality x plus 6 times x minus 2 greater than 0 is equivalent to our original inequality, which was 3x minus 8 over 2x minus 1 greater than x minus 4 over x plus 1. So therefore the solution to, so our final solution is for x plus 6 times x minus 2 greater than 0 is the same as the solution to our original inequality. All right, so that brings us to the end of our session today. If you have any questions, please send us a note to info@raisebymarks.com or give us a call. We look forward to seeing you again. Thank you.